Hello and welcome to this Osmocalc knowledge base video. In this demonstration, we'll look at how milk replacer composition and solids concentration affect the calculation of osmolality. Let's get started. When we open the Osmocalc program, we typically load the file name osmolalitydefaultvalues.csv. This file contains a standard osmolality calculation using milk replacer powder and water. In the first column, we see the milk replacer composition: dry matter, protein, fat, ash, and other components. In the third column, we see the solids concentration of the water, expressed in milligrams per liter. In this example, we are feeding 650 grams of milk replacer powder and 5,350 grams or milliliters of water. The water contains about 400 milligrams per liter of dissolved solids, including a small amounts of sodium and calcium and trace amounts of potassium and magnesium. Lactose is calculated using the equation 100 minus water, protein, fat, ash, and other listed components. In this case, lactose is calculated at 45%. This is an important assumption because, as shown in the second column, lactose contributes the majority of osmoles in the final solution. The mineral concentrations are listed below lactose and also contribute to overall osmolality. At this mixing rate, about 10% solids, the milk replacer contributes approximately 1,525 milliosmoles, while the water contributes only about 16 milliosmoles. The total osmolality column sums both sources, giving a total of 1,541 milliosmoles in a 6-liter solution. This results in an osmolality of 257 milliosmoles per kilo. Now let's look at the effect of increasing solids concentration. I'll increase the milk replacer to 800 grams and reduce the water to 2,400 milliliters, creating a 5-liter solution. The solids concentration recalculates to about 15%, and the osmolality increases to 378 milliosmoles per kilogram. Since our upper acceptable breakpoint is 450, we're still in the green zone. If I increase further to 1,000 grams of powder in 4 liters of water, again making a 5-liter solution, the solids concentration rises to about 19% and the osmolality increases to 472. That exceeds our upper limit of 450, placing us in the caution zone. As we increase solids concentration, the number of total osmoles in the solution naturally increases. If we concentrate even further, reducing water to make a 4-liter solution, we approach 23 to 24% solids, and the osmolality rises to nearly 600 milliosmoles per kilogram. At that point, we are clearly in the danger zone. This demonstrates that solids concentration has a profound effect on osmolality when mixing milk replacer. Now let's return to our 800 grams and 4,200 milliliters of water, giving us 378 milliosmoles per kilo. Now let's look at the effect of composition. If I adjust the protein and fat levels to a typical 20/20 milk replacer, osmolality increases slightly, from 378 to 387. That's a relatively small change. Minerals, however, can have a larger impact. For example, if sodium and chloride increase from 0.5 to 1%, osmolality rises to 445. That brings us very close to our upper acceptable limit. It's important to understand mineral concentrations, even though they may not always be listed in detail on the feed tag. Your feed supplier should be able to provide a full mineral analysis. Macrominerals have the greatest impact on osmolality. Microminerals rarely contribute enough to make a meaningful difference. That concludes this episode. Thanks for watching, and be sure to check out other Osmocalc knowledge-based videos to learn how to get the most out of the program.